So we are in discussion of group 16 elements. About hydrates we were discussing. Now we'll go with oxides. Oxygen dioxide, OO2, you can call it as O3. Okay, so two types of oxides are possible, EO2, EO3, dioxides and trioxides. Like sulfur dioxide, easy you can remember. Sulfur trioxide, or selenium dioxide, all dioxides and all trioxides are acidic in nature. First point to remember. SO2 plus water, H2SO3, sulfurous acid. SO3 plus water, sulfuric acid. So SO2 you can say anhydride of sulfurous acid. SO3 is anhydride of sulfuric acid. Very simple. Coming to the dioxides. SO2 is a reducing agent. Sulfur dioxide, selenium dioxide, tellurium dioxide. Tellurium dioxide is an oxidizing agent. Sulfur dioxide is reducing and tellurium dioxide is oxidizing. So important point. Question. Sulfur dioxide is a reducing agent and it is a bleaching agent, and its bleaching action is because of reduction. Generally, all bleaching compounds like hydrogen peroxide, ozone or bleaching powder and all this, they do bleaching because of oxidation, and this is because of reduction. So very special. And one interesting point is it is temporary reduction, not permanent reduction. It's a temporary bleaching, not permanent bleaching. So SO2 temporary bleaching and reduction bleaching. Bleaching is because of reduction. One important point. Then about SO2, how is SO2 prepared? S plus O2 SO2. I will take sulfides, SO3 minus 2. The sulfides, when they are treated with H plus, SO2 gas is coming out. SO3 minus 2 plus 2H plus SO2 plus water. It will be coming out, sulfur dioxide. Otherwise, take any sulfide ore, zinc sulfide, lead sulfide, iron sulfide, copper sulfide, burn. This process we are calling in metallurgy. Okay, when sulfide ores are burned in oxygen, this is roasting. In roasting, you will be getting the sulfur dioxide. Preparation of sulfur dioxide. Sulfur dioxide, pungent smell, strong. And nature is, when it comes to the nature of sulfur dioxide, it is acidic in nature. Then sulfur dioxide properties. Sulfur dioxide is a reducing agent and reduces KMnO4, potassium permanganate to Mn plus 2, KMnO4 to Mn plus 2, iron plus 3 to iron plus 2, Fe plus 3 is reduced to Fe plus 2. One special point. It can add with chlorine, SO2 plus Cl2, SO2 Cl2. It can add with oxygen, SO2 plus O2 gives us SO3. And one very special reaction is, when it reacts with bases, it behaves like carbon dioxide. For example, you studied from your childhood. When carbon dioxide is passed through lime water, it turns it milky. If you are passing it for a long time, that milky turns into clear solution. Right? First calcium carbonate is formed, then it turns into calcium bicarbonate. Same thing when you are passing sulfur dioxide through base solution, for example NaOH. First Na2SO3 is formed. Further, if you are passing carbon dioxide, that Na2SO3 is converted to sodium bisulfite, NaHSO3. So it behaves like carbon dioxide when it reacts with bases. One other special property. SO2 when dropped in water forms H2SO3. H2SO3 is a weak acid. H2SO3 is a dibasic acid. About H2SO3 acidic nature and all we will discuss in another category. Okay, so this is about SO2 preparation. And structure of SO2, if you see, this is very interesting. sp2 hybridization, bend shape, two bonds will be there, double bond. Yes, okay, here S will be there, double bond O, double bond O. In that one is sigma, we know, in a double bond one is sigma. Second pi bond is, one pi bond is p pi bond, that is sulfur's p bond, p orbital, and oxygen's p orbital, p pi bond. Another bond is a d pi bond, whereas sulfur's d orbital is used and p orbital of oxygen. So one p pi, one d pi. That is in SO2. Okay. SO2 angular, SO2 acidic, SO2 gas, SO2 reducing agent. All these are about oxides. Then coming to the halides. Okay, now in this video we will complete halides also. If you are taking this group element as EX6, EX4, EX2, E2H2, EX6 hexa, EX4 tetra, EX2 di, E2H2 mono. All these are possible. Coming to hexa. Hexa fluorides only we say, because only fluorides are possible. Remaining are not possible, only fluorides. In that SF6 is exceptionally stable. SF6 octahedral sp3d2 hybridization, 6 sigma bonds will be there. Nothing much about SF6. Tetrahalides, if you take tetrahalides, I am using. Okay, and there I said hexafluorides. It is tetrafluorides, all are possible. In this, SF4 is a gas, SeF4 is a liquid, and TeF4 is solid. So down the group, gas turning into liquid into solid. So these are particularly mentioned in NCERT. So you can expect in NEET or JEE. Okay, now you can expect this. Then all these are having one lone pair. So sp3 dehybridization, one lone pair, seesaw geometry, seesaw. In case of SF4 type. Then SCl2, that is EX2 type category, SCl2, sp3 hybridization, 2 sigma bonds and 2 lone pairs will be there. Very routine about that. Oxygen cannot form easily OBr2, OA2 type of compounds. OCl2 is known to us, 111 degrees cycle, but OBr2, OA2 compounds are not known. Coming to last, S2Cl2 type, that is monohalides. In monohalides, generally they will be having open book shape, as we see in case of hydrogen peroxide, open book shape. Okay, hydrogen, oxygen, oxygen, hydrogen, open book shape. Okay, when you are opening book like this. Okay, this is called spine. 2 oxygens will be here, 1 hydrogen will be here, 1 hydrogen will be here. Hydrogen, oxygen, oxygen, hydrogen, open book shape. Then coming to the next, S2Cl2, this kind of compound we undergo disproportionation. S2Cl2 gives you S and SCl4. S2Cl2 where sulfur oxidation state is +1 turns into S0 and SCl4 +4. Disproportionation. About halides, these are the important lines. About oxides and halides we are discussing now. We will discuss about oxyacids in coming videos.